water acting as an amphiprotic substance. Okay, that means water acting as an acid and as a base. So we'll write one equation in which water reacts as an acid, one equation in which water acts as a base. So if we want water as an acid, well, what do we react acids with? We react acids with bases. So let's pick a base for water to react with. I'm going to pick the carbonate ion here. I'm not going to pick hydroxide because we end up with a circular equation there and that just looks silly. So water is going to lose a proton, because that's what acids do, turn into hydroxide. Carbonate is going to gain a proton, because that's what bases do. Ends up as hydrogen carbonate. Okay, so now we're going to have water acting as a base. If we want to show something acting as a base, what are we going to react it with? Well, an acid is clearly what is going to show it. So let's pick the simplest acid, HCl. So the base will gain a proton, water will turn into H3O+, HCl will lose a proton, turn into Cl-. Carbonic acid acting as a diprotic acid. That means carbonic acid losing 2 protons. Equations, well, we can write this as 2 separate equations, but I'm feeling a bit lazy, so I'm just going to write it as one equation. So one equation in which it's going to lose both of those H's. So we're going to start off with H2CO3. And we're going to react it with 2 base molecules, because each one of those base molecules is going to accept a proton. So how about ammonia as a good base? So carbonic acid loses its 2 protons, turn into the carbonate ion, and each of the 2 ammonium molecules gain a proton to end up as ammonium. Diprotic because it's lost 2 protons. On to 3 and 4. Okay, H2SO4 is a strong acid. Why is H2SO4 strong acid? Well, because it does what strong acids do, and it ionises to a large extent, almost fully. First ionisation is pretty much complete. Now, our sulfuric acid solution, is it dilute or concentrated? Well, that tells us what amount of sulfuric acid is in our litre of water. And we see it's only 0.01 moles in a litre of water. That is dilute because such a small amount, only 0.01 0.01 moles has been added to our 1 litre. So a small amount in a large volume, therefore it's a dilute solution. Okay, 10 moles of ammonium ions have been added to a litre of water. Well, it's a weak acid for the reverse of the reason from question 3. Because it ionises poorly. That means few H3O plus ions are produced. Concentrated or dilute? Well, if we're adding 10 mils of ammonium to a litre of water, that is a concentrated solution. Large volume. A large amount has been added to a litre of water. And finally, question 5. Which has the stronger conjugate base, hydrochloric acid or ethanoic acid? Well, the principle we go by is that the stronger the acid, the weaker its conjugate base. So HCl is a very strong acid. Ethanoic acid is a weak acid. Therefore, weak conjugate base, ethanoic acid is a weak acid, therefore a stronger conjugate base.